Now we're going to look at what happens when the man is moving at a speed that is not constant. So we're going to start with acceleration. And acceleration depends whether he's moving away from his origin or target or if he's moving towards it. So right now he's starting at 0, so that is his origin or his target. So if he is accelerating, which means speeding up, and he is moving away from his target, we'll see what happens. Now, because he is moving fast, he might crash into the wall and you might hear him groan, but let's see what happens when he accelerates. So you can see the slight curve to the graph before he crashed into the wall, and that's where it started leveling out. But the increase was slow at first, and then as he speeds up, the curve gets steeper and steeper. So that's what accelerating away from his origin or his target looks like. Now, if we were going to accelerate towards the target, so we're going to put him at a distance of 10 meters. And change his acceleration because he's going to be going the opposite direction. So now he is 10 meters away and he's going to be accelerating towards the target. So he's going to be speeding up as he gets closer to 0, because 0 is where the origin, where he started, where his target is. So if you watch the man, he's going to be getting, as he gets closer to the target at 0 meters, he's going to be speeding up. And you can watch him move and see him go faster, and then you can look at what happens to the graph. So as he moved faster, the graph is curving again. Anytime there's a curve, it means that the speed at which he is traveling is not constant. And the graph is going down because he is getting closer to his target. And it starts off not as steep, and it's curving and getting steeper and steeper the faster he gets. All right, now we're going to look at deceleration. So we're going to change this. You don't have to worry about these numbers because you won't have to change these. I just can't pause this while I do this. All right, so here he goes. He's going to be going away from his target. So he's starting at the origin, starting at his target, and he's going to start off fast, and then he's going to get slower. He's slowing down, and you can see that the graph curves again because he's not traveling at a steady pace, and it is moving upwards because he's going away from the target, which is the origin, which is 0 meters, and it's starting off steep and it's becoming less steep. You see, as I got to the top, you can kind of see that before I stopped it, he turned around and he kind of started to come back, and that's why the graph started going back down. But at the beginning, before he turned around, the graph curved, it went up, and it started steep and became less steep. So that's what deceleration would look like. And the last thing we're going to look at is deceleration moving towards the target. So we're going to put him at 10 meters away. Again, you don't need to worry about these numbers here. You just need to worry about what the graph looks like afterwards. All right, so he's going to start 10 meters away, and he is going to move towards the target, towards the origin, which is towards 0, and he's going to decelerate, which means he's going to slow down. So watch him move, watch him slow down, and then take a look at the graph. There, he's moved. All right, so again, he kind of turned around before I stopped it, but the graph is curved because he is not traveling at a steady pace. It is going down because he was moving towards the target, so his position was getting smaller. and it started off steeper, and as he slowed down, the curvature became less steep. So that is acceleration and deceleration.